Hello students, today we are going to go over the second half of lesson 10.5, which is covering dependent events. So events are dependent events if the occurrence of one event does, this is a keyword, affect the likelihood that the other event will occur, okay? So the first probability will just be normal. It'll be what you think it is, but the second one will be affected from the first. So let's take a look at first this key idea. Okay, so the probability of two dependent events A and B is the probability of A, okay, times the probability of B after A occurs. Okay, so we are assuming that that first event A happens. Okay, so let's take a look. Might make a little more sense with an example. Okay, so people are randomly chosen to be on a game show. Contestants from an audience of 100 people. So if you've ever seen The Price is Right, you could think about that. Might be a little past your time though. You are with 5 of your relatives and 6 other friends. First, we need to find the probability that one of your relatives is chosen first, okay, and then one of your friends is chosen second. Okay, so out of the total of, the first thing we need to find is your relatives. Okay, so out of the total 100 people that are in the audience, you have 5 relatives. Okay, so this is nothing new. 5 out of the total 100 people. Let's just simplify that really quick by dividing the top and the bottom by 5, and we get 1 out of 20. Okay, next, we are assuming that this happens, okay? So when this happens, that one person out of the 100 people was picked, okay? And you can think about it that they're not going back in the stands, they're picked, they're up on stage. So now you only have 99 people left in the audience because this thing happened, okay? And now we need to think about how many of your friends we have in the stands left, and that there are 6. Okay, let's simplify this as well. Divide the top and the bottom by 3. 6 divided by 3 is 2. 99 divided by 3 is going to be 33. And finally, all we need to do now is multiply our two probabilities together. So the probability of picking a relative was 1/20th, and the probability of picking a friend after that relative was chosen, so P after B, that's what that means, was 2 out of 33. Finally, we can multiply across to get 20 times 33 is 660. So then we finally just need to simplify our probability by dividing the top and the bottom by 2. 2 divided by 2 is just 1, and 660 divided by 2 is 330. Okay, so you have a 1 in 330 chance that the relative would be chosen and then your friend would be chosen on this game show. Okay, we have an extra example. What is the probability that one of your friends is chosen first, okay, and then that you are chosen second? Okay, so first find the probability of your friend chosen first. Okay, so you start with those 100 people in the audience, and you have 6 friends in the audience, so 6 out of 100. Next, we assume that this happens. One of the friends was chosen. Okay, so that there were 100 people in the audience, and after that happens, there's only 99 left. Okay, and the probability that you were chosen out of that 99 people, there's only one you, so 1 out of 99. Now we can multiply across. 6 times 1 is 6, and 100 times 99 is 9,900. And now we just have some simplifying to do. We can divide the top and the bottom by 6 and get 1,650 in the denominator. So there's a very slim chance that your friend and you are going to be up on stage together. Okay, this one is on your own. We have one more example. Follow the pattern that we have done before. Pause the video and see if you can do it. Okay, so let's go over this. It says, what is the probability that you, your relatives, and your friends are not chosen to be either of the first two contestants? So this one actually is a little bit more difficult. So let's start by thinking about there's 100 people in the audience to start, and you is one person, your friends were 6 people, and your relatives were 5 people. So I'm going to go ahead and add those up. 1 plus 6 plus 5 is 12. Okay. So that is how many people that you are associated with, right? So if we said 12 out of 100 people, that would be the probability that you know someone or yourself that gets chosen. But it is asking that are not chosen. Okay, so you actually want to take that 100 and subtract 12 to get 88 of those people in the stands that are not either you, your relatives, or your friends. Okay, so 88 out of 100 people are either you, not your relatives, or not your friends. Okay, so now we assume that that happens. Okay, that one of those random people were picked, and there are 99 people left in the stands. Okay, and now one of those random people were picked, so now left in the stands that is not you, your friends, or your relatives is 87 people. Before we multiply across, I am just going to simplify a little bit first. So I know that I can simplify this fraction by dividing the top and the bottom by 4. So 88 divided by 4 will be 22, and 100 divided by 4 will be 25. Okay, I can simplify this second fraction by dividing the top and the bottom by 3. 87 divided by 3 is 29, and 99 divided by 3 is 33. So now I'm just working with smaller numbers. When I multiply across now, 22 times 29 is 638, and 25 times 33 is 825. And now if I just type that into my calculator, 638 divided by 825, you will get a decimal, which is 0.773. You know, from our decimals and percent units, we can move the decimal 2 places over or multiply by 100 to get that there is a 77.3% chance that you, your relatives, and your friends are not going to be chosen to be either one of the first 2 contestants. So there's obviously a very high probability that, unfortunately, someone you know or yourself is not going to get chosen. Okay, so today's video we covered just one example of a dependent event. Remember, dependent events are talking about events that depend on each other. Okay, so the probability of the second event is affected by the first. Okay, so you want to assume that it happens. A lot of times you'll get examples with marbles. Okay, so if you get a bunch of colored marbles, and they're saying, okay, you're not going to put it back in the bag. Okay, so you assume that that specific marble, that first probability, it happened, and you take it out of the bag without replacing it back in the bag. So that's something that you might hear in some of your homework problems.